All right, so let's think about what we can do for part B. So we have ln 4 plus x squared dx, and we don't have a direct formula to integrate ln type functions. So I think this is another good application of integrating by parts. So going back to L.I.A.T.E, the acronyms, remember, L.I.A.T.E, we have the logarithmic function, and we're going to do the same trick that we did earlier. So I'm going to put a hypothetical 1 as a multiple, and 1 is a constant function. That's an algebraic function. So that's going to serve as the second function to apply the integrating by parts. Okay? So again, what I'm going to do here is, well, first, by the way, let's take care of the indefinite integral. So let me just write here. So I'm interested in first finding the antiderivative of this function. So for that reason, I'm going to put a hypothetical 1 here so that I have logarithmic against algebraic. So logarithmic 1 is the one that I'm calling for u. Okay, so ln 4 plus x squared is u, and then dv equals 1 times dx essentially, which is just dx. Okay? So du is the derivative of ln of a function. That's the derivative of inside divided by itself. And you can check the derivative formula card for that. And here v is simply just x. All right, so let's go ahead and write down the integration by parts formula. U times v, so x times ln 4 plus x squared, minus v times du. So now I have 2x squared over 4 plus x squared dx. All right. Let's think about what we can do for the second integral. So you have x squared term here, another 4 plus x squared at the bottom. So we may apply a good algebra here because top and the bottom are like terms. So I may make the top look like the bottom by adding and subtracting a constant. So in fact, what I'm trying to say is, why don't we add 4 to the top and then subtract 4 as well, and split the fractions. This is one of the known tricks that we mentioned in earlier section. In fact, in 8.1, basic integration rules and manipulation by using algebra and trig. So this way, I can sort of like write this as like 1 minus 4 over 4 plus x squared. And I split this into two different integrals. Okay? So think about this, and I'm going to erase this part and I just write the final output in the next step. Okay, there we go. So it's x ln 4 plus x squared minus 2 in the bracket. Okay, 1 minus in the integral, obviously, dx minus 4 dx over 4 plus x squared. Okay. All right, at this moment, I want you to recall this formula here, du over a squared over u squared. It's number 19 to evaluate this integral. Okay, so a is 2 here, right? So 2 squared is 4. 4 plus x squared. Okay, so this is integrated as, let me just write down here. Let me just copy everything down first. Minus 2. And this dx is integrated as just x, right? Minus 4. So it's 1 over a. 1 over a. So 4 over 2. Arctan. Let me just save some space here. Okay. Arctan u over 8. So x over 2. Okay. And plus c. Okay, so you should recall this formula to be able to handle this problem correctly. Okay, so in the next step, I'm going to simplify the final output. Here we go. I simplified this term right here. Let me just put it up, underline that with red mark. Okay. So this is the value of the indefinite integral. What I'm being asked is this definite integral from 0 to 1. So essentially, I'm going to use the fundamental theorem of calculus to evaluate that integral. Okay. So let's just do that. Essentially, I'm going to plug in 1 and 0 in this description. I don't need a C here, so I will just get rid of that. Okay, and I have to clean up a little bit. I'll come back. All right, so I cleaned up everything, so we can continue from here. So I'm going to plug in 1. So ln 5 minus 2 plus 4 arctan 1/2. That's me plugging in just 1 first. And then I'm going to plug in 0. And x times ln term is going to be 0 because x is 0. 2x term is going to be 0. Only 4 arctan 0 is going to survive. 4 arctan 0. Okay. All right. So arctan 0, if you use your calculator, this is 0. So the final output in the exact expression form, it's ln 5 minus 2 plus 4 arc tan 1/2. And you can go ahead and use your calculator to get an approximate value here. And I wrote the value of arctan 0 as 0 here because it's a well-known value for arctan, so it's just 0. I just wanted to just write that down right away. But if you want to get an approximate value, this is equal to 1.464. Okay, so I can go ahead here that this is 1.464 as the value of the integral obtained by applying the integration by parts formula and also using some algebra to get to the final number 1.464. All right, so I'm going to end the video right here. That takes care of part B. So we are done with all the sub-questions here. And if you have any questions or comments, please send those to my way. And I'll see you in another video. Bye.